Okay, let's start by trying to answer some of these questions then. So we're going to have to decide whether or not we're going to use the sine rule or the cos rule. Well, let's just try to study the differences between them. The cos rule contains all three lengths and one angle, whereas the sine rule, depending on basically it's saying any two any two sides with their opposite angles. So you're going to be with the sine rule, you're going to be considering any two angles along with any two sides, and you're going to one of those four values you're going to not know but needs to know. With the cos rule, you'll be working with all three sides, so you may know two, and you need to know the third, and an angle. So you got again that's four. So there's four variables in each case. The cos rule, the variables are side A, side B, side C, and angle A, which is opposite side A. And then the four variables you're working with in the sine rule situation is one side and its opposite angle, and another side and its opposite angle. Okay, don't get confused by these two equal signs. It's really just emphasizing the fact this is the case for any sides of a three-sided triangle. Well, all triangles are three-sided, of course. Right, so we've got a scalene triangle, a triangle that doesn't follow, that we cannot use standard trigonometry for. What do we need to know? Well, we have two sides and we have a missing side. So we're thinking about all three sides. So straight away, I know it's the cos rule that I need to look at. So what I'm going to do, I'm just going to go over here. I'm going to use my snipping tool to grab these. Actually, I think so. Just get a new snip like that, and I'm going to then go over here and paste it and then chop it into three. Oh, I'll just keep it all as one actually, and shrink it quite a bit. Okay, I can move this around as I'm working then now. Shrink it a little bit more. Just need to be able to read it. So right, let's label what's what here. X is opposite the one angle we know. With the cos rule, that would be A. Oh, and it's labeled at A. That's nice. That's nice of it. So this is little a. It's labeled the other one's B, so that would be little b is equal to that. And oh, sorry, no, not little b, little c is equal to that, and this is little b is equal to that. Okay, so they're helping us slightly by writing they're labeling the corners and also labeling the corners correctly, as in the capital A is where the one angle is. So yeah. So now we just have to sub the values in, and we'd have to rearrange it. So a squared, which is x squared, is equal to b squared. So I'm not going to write all that out actually. We can see what the formula is over there. So let's just write x squared is equal to b squared, which is 5 squared, plus c squared, which is 6 squared, minus 2 times b, which is 5, times c, which is 6, times cos a. Cos a is 30. Okay, so we'll just tap that into our calculator. I think what I'm actually going to do here actually is introduce the other concept of what do they call so there are some values of cos 30s, well basically 30, 60, 45, 90, and 0 are all angles you need to be aware of. So the cos identities and sine identities you need to be aware of. So cos 30 is actually root 3 over 2. If you've got a scientific calculator, it actually does tell you that. So we'll try to avoid using the calculator till the very end, and maybe we can be really clever and put the answer in a third. So 25 plus 6 squared is 36, minus 2 times 5, 10 times 6 is 60, and cos 30 is root, let's write it like this, root 3, and then all over 2. Okay, so 25 plus 36. Well, I'm going to use a calculator for that because don't want to time my brain out. Okay, so 25 plus 36, 61. Actually, not too hard really, but 60 root 3 over 2 is 30 root 3. So that is the simplified surd you can get. And in this case, I'm just combining surds and I'm combining these standard trig values, which you need to be aware of, just into one question. But you could you could just tap all this in, and maybe we can see if I've done it right here. So let's do 61 minus 30 root 3, and press the button to turn it into a decimal, and we have 9.04 rounding up, or maybe 9 to 2 decimal places, 9.0 to 2 decimal places, to 2 significant figures. 2 significant figures. Doesn't. Oh, it says to 1 decimal place. Oh, I've done it to 1 decimal place anyway. It's the same thing. So, right, it's 9.0 to 1 decimal place. So let's check to see if I've got that right around. If I just did it without this root 3 business. So we're doing 5 squared plus 6 squared minus, I'm going to put this in brackets, just as a good habit. Don't actually need to be fair. Cos 30, close bracket, equals, and yeah, I've got it right. Good, didn't mess up there. So 9.0 to 1 decimal place. Okay, as I said, that was just me sticking another bit of sort of revision stuff on the end of it. Let's do one more. So a diagram below shows a triangle. What do we have? We've got 3 sides. That means it's the Cos rule again. Okay, this time it's going to be they are trying to trick us this time because we've labeled it A, B, and C, but not correctly. I'll show you what I mean. I'll get the Cos rule thing over here. As you can see, the Cos rule, AB squared. So capital A, which is the angle we're looking at, they've labelled as capital C. So capital A is equal to capital C as far as the formula is concerned, the standard formula. So so we're trying to work out. Well, let's start off by writing that out. No, let's start off by rearranging all of this. Okay, so I'm going to say A squared minus B squared minus C squared would be equal to let's well, actually no, let's change that. I think you want to try to rearrange this yourself, but I'm going to rearrange it. So I'm going to jump a few steps, and then I want to see if you can try to rearrange it and get the same answer. But I also would like to see how much of this you can do in your head, like I'm going to attempt to do. I'll describe it as I'm doing it. So this is what I'm doing in my head. I'm moving the 2BC cos A over to the other side, and so that turns a negative into a plus, and then I'm going to minus the A squared over to that side, so which means that I end up with, so I'm not doing the whole thing in my head, but I'm doing just the odd step in my head. So that ends up with that is equal to B squared plus C squared minus A squared. Okay. So what do we have now? Okay. All right. So I've just rearranged the formula there, and now what we can start to do is sub these values. Oh no. Now I want to rearrange it even further, don't I? So now let's do cos A is equal to, and we're going to divide everything by 2bc. So plus c squared minus a squared, and then all divided by 2bc. And this is not going to give us a, this is going to give us cos a. So we want to do the inverse cos function on both sides. So in other words, if I do inverse cos function on the right, and if I also do it on the left as well, that will give me just angle A. So that will be what the final sum will be. Let's shrink all this so we can now sub the values in. So we've got a, which is actually x. So x is going to be equal to cos to the minus 1 all of b squared, which can be basically any of the other two sides. The a squared is this, and as you can see, 12, and this kind of makes sense, doesn't it? Because 7 squared plus 10 squared would be the same as 10 squared plus 7 squared. So it doesn't matter which way around it is, and so that kind of makes sense. Obviously, minus, we need to make sure we minus the right one, and it's the a, which is opposite the angle we're trying to find out. So we're going to be minusing 12 squared. You'll notice that this cos rule looks quite a lot like the Pythagoras rule, okay, and the sine rule looks a little bit similar to the one of the sine rule in the you can probably have a little bit of fun with these and play around with them. Imagine that one of the angles was 90 degrees, and you'll find out that it's going to be very similar to the other equations which we know of. So essentially, this is the previous trigonometry rules we've been looking at are essentially simplified versions of this one. Oops, let me just pause this for. Yeah, so I'll just have to check if I was teaching in a moment. So 2BC. What are we doing now? Okay, so then it's going to be 2 times, so BC are the other 2, so 7 times 10. Okay, so which is going to be equal to cos to the minus 1. Now, the reason why to not do not use a calculator more than once in sums is to reduce, 1, to save time, and 2, to reduce any errors. In this case, we've got all integers. We're not dividing. Well, we are going to divide, but what we're going to do, I'm going to do it all in one calculation. So I'm going to do shift cos, which gives me inverse cos. So 7 squared plus 10 squared minus 12 squared, and close bracket. I want to put a second bracket before the 7 squared, and then I'm going to take so that's put the whole of the top half of this bit in one set of brackets. They're going to divide it by and open another bracket, then do 2 times 7 times 10, and then close that bracket, and then close the bracket which had the inverse cos function. And I get an error because I've done something wrong. Missed out a plus symbol. No, a minus symbol. Let's try that again. Cool. Right. Okay. So I don't need to put all that in there. I can just I get the answer should be 87.9 degrees. Oops. Right. So, hang on a second. Right. So 87.95 degrees. So give your answer to an appropriate degree of accuracy. Well, what does this mean? Well, basically the data we've been given is to 1 or 2 significant figures. So that's 2 significant figures. That could be 1 or 2. That's 1 significant figure. So we can use best to use. You can, in this situation, because we've got this one to 1 significant figure, and this one could be 1 significant figure. We're going to allow ourselves 1 extra significant figure. In other words, 2 significant figures, which is 88 degrees. So that's the appropriate level of accuracy which we allowed to use. Okay, hope that makes sense.